Okay, so chapter 4, lesson 4, this is um, adding and subtracting unlike fractions. So, the only thing that's going to be different today is that you have to change the denominator. That's the only thing that's different. And we kind of have some background on that already because we had to do that for comparing different fractions. So, let's just add these together just to make sure we're on the same page, just to make sure we remember how to do yesterday's. So let's talk about it. We don't got to do them on your paper. Let's just talk about them together. So 4 9 plus 4 9. So what has to stay? The what? What has to stay? Haley? Okay. And then I have 4 plus 4, which is 8. Is this reducible? No. That's the answer. That's the answer. Okay. So I have 3 6 plus 5 6. 6 is going to stay. What's my top number going to be, though? McKenna? 8. Yep, it goes into improper fraction. So if you aren't sure, you're right. It's 1 and 2 6, which reduces 1 and 2 6 reduces to what? Should be 1 and a third, I believe, because you can reduce it by 2. Does everybody remember how to do that kind of stuff? Because you're also going to have to do that today, okay? But there's just a step beforehand that we have to do before we get to this part. So we've talked about unlike denominators before. What are some ways you can find like denominators? Like if two things are different. Let's say I have 4 and, say, 5. How can I find a like denominator for those? Kira. Yep. So if I just multiply the two bottom numbers, that's going to automatically give me a denominator, you guys. So if you can't think of something, multiply them together. That makes it really simple. Yeah. What if I have denominators that look like this? What about something like this? What can I do here, Maddie? Yeah, I could just change this one because I know 15, that 5 shares 15, so I can keep 15. If you don't know that, what could you do? You could multiply them together. Or you could times, yeah, like 30. They both go into 30. You could do that too. It's totally up to you what you want to do. Whatever Logan uses and whatever Haley uses should come to be the same answer if you reduce correctly. So if you reduce correctly, everybody should have the same answer here depending, it doesn't matter what denominator you use. Okay, it only depends on if you reduce correctly. So, all right, so let's talk about some of these. Okay, so let's practice. Let's practice. If you need some practice, this is your time. So I have 3/5 minus 1/3. What's a denominator I can use here? We kind of just talked about one like this, yeah. 15. Let's use 15. Now, I don't know how Mrs. Schneider has you write them on your paper. I don't really know. I think she probably has you write it like this. Does that look familiar? I don't know how you had to write it. I'm not sure. But I write mine like this. Because I always do mine below. And I say, okay, I took this times 5, so what do I have to take this times then? 5. Yep, so this is my new fraction. If I took this times 3, what do I have to take this times then? Yeah, there we go. Now I can subtract, and it turns into what you did yesterday. So the only difference is today is that we have to change the denominator before we do our adding and subtracting. Okay, so this turns into be what? I'm going to subtract 4/15. Reducible? What do you think? No. 2 doesn't go into 15, 4 doesn't go into 15. This is it. The end. If there's a negative in there. There's no negative in there. There's no negative. So that will happen today again. That will happen today again. Alright, so what am I going to use for a denominator over here on this side? What am I going to use for a denominator over here? I have 2 and 22. What do you think, Haley? Not 11. But I know what you mean. What are we going to use for the denominator? I know what you mean. What's going to be our bottom number? What can our bottom number be? Yeah? 22. Now, keep watching. Can this one stay? Yes. What am I going to multiply that by then? Then I'm going to multiply by 11. So you were on the right track. You're on the right track. So I multiplied this by 11. Guess what I'm going to have to multiply that by? 11. Now I can add together. I think you were thinking about this, but you were kind of a little confused about what number I was asking. So then I get 18 out of 22. I can reduce by 2. Yep, 9 over 11. And that is the end, folks. Any questions so far? Any questions? Alright, let's try some more. Why don't you try these yourself? Try these yourself. And then we're going to do some ones that have negatives. Okay, you guys ready to share? Any more second? Any more seconds? Okay, let's talk about the first one. What did you do for the denominator for the first one? What did you do, Kira? Good. So 16 or 9 over 16, and then you had to change it to 2 over 16. Does that sound right? Is that what everybody 2 over 16? Is that how what 1/8 comes to? And then what did you get for an answer? What did you get for an answer for the first one? McKenna. 7/16. That sounds pretty good to me. That sound pretty good to you? Okay, let's talk about the next one. What did you use for denominator? There's a few things I know people probably used in here. What did you use, McKenna? So you did 20. Anybody use 40? Base for it? Okay. So regardless of what she gets for an answer, you should probably get the same thing. So then it was 5 over 20. That's McKenna, right, McKenna? And then 6 over 20. So what did you have for an answer then? Yeah. Oh. Oh, so you multiply by 10. So you got to be careful. So if you multiply by, because you said you used 20, right? 20, 20. So this times would have been 5. So I'm going to multiply by 5 there. And then times 2, so that would have been 6. And then you should have gotten 11/20ths. Regardless, if you did it and you got if you did 40 as a common denominator, you probably got 22 over 40. And then it can be reduced by 2. Okay? So see what I mean? No matter what, either way, you should end up with the correct answer regardless of what denominator you choose, unless it's not a correct denominator. Okay. All right, did you guys figure yours out now? All right, what questions do we have so far? It's just all about practice, really. Just all about practice. Let's throw one with negative in there now, okay? Because there's going to be some like this again today. So if you remembered how to do yesterday and you did yours correctly yesterday, you should be able to do these. First thing you need to do, though, is change the denominator. Don't even worry about keep, change, change. So we have all the denominators changed, okay? So what would you use here for a denominator? What would you use, Logan? I would use 6 too. Yep, I would use 6 too. That's simple. Okay, so I multiply by 2, so I'm going to multiply this by 2. I multiply this by 3, so I multiply this by 3. what it looks like. But I got to keep my negatives with it. All right, so how does that look? Now tell me what to do. Now tell me what to do. Do you remember, Maddie? Okay, so I'm going to keep the 6, but I'm going to keep this. I'm going to change this, and what am I going to do with this then? Yep, so I have -4 plus -3. What's -4 plus -3? Go ahead. -7, -7, 6. Yep, -1 and 1, 6. Okay, if you need to draw out your cats and your dogs, draw your cats and your dogs. I don't care. Do that. If you need to do it, go for it. Go for it. I swear. Let's do another one. Let's do another one. Let's do another one. Try this one. You want to try this one yourself? Try this one yourself. See if you can get it. Try this one yourself. See if you can get it. Do your denominators first. That's rule 1. Then worry about your keep, change stuff. It gets easier as you do it. It gets easier as you do it. There's actually 1, 2. I'm going to throw 1 more in. Just for fun. How we doing? So far, so good? It gets easier as you practice this. It really does. It gets easier as you do it. Alright, so what denominator did you use? Does anybody need another second? I'm sorry. Did anybody need another second? Kayla, you good? Okay. What did you use, Kira? Yeah, that's what I would have done. Okay, times 5, so times 5. Times 2, so times 2, and then I'm going to put my signs back in. Oh, that's not a negative. My bad. I have 2 negatives, actually. Looks like this and like this. So then what? What did you do next? What did you do next? Desi. So keeping this guy, changing this guy, changing this, and you should have got 9 over 10. Good. Nice job. 9 over 10. I'm going to show you one more you're going to see in your homework today, and it's going to look like this. So what do you think you would have to do here? What would you do here first, Maddie? Yeah, you're going to do this first. Figure out your denominators. Let's see, I'm going to keep a 4 plus, this is going to be 2 4s, times 2 times 2. So this is going to be, 4 over 4. Well, that's easy enough. So what's that really like? 1. And then I'm going to add your 3/8 to that. It's not always going to turn out this easy. It just happened to this time. Okay. But you might have to change denominators a few times because you're going to get this one figured out. And then you might have to change it again to compare with your other ones. So careful with that also. If you have ones like this, okay, let's say you changed the denominators already. So you changed them already. I did that for you. How would I solve a problem like this now? What am I going to add together? What am I going to add together? What am I going to add? Yep. 2 plus -3, because what happens to this guy, it comes up to him. So be careful with those also, because you're going to see some with addition, too, that have negatives in it. Okay? So you're going to see some subtraction with negatives. You're going to see some regular ones. You're going to see some story problems, okay, like you did yesterday. Some of you are kind of confused on the story problems. Find a key word. Say if it's more than, or if it's together. Think of what you're going to do with those different fractions. Okay. Anybody have questions for me? That's really my lesson today. So, and you get out of here at about 9 o'clock. So you have approximately 10 minutes to work, and then we can answer questions if you get to questions into homework. Okay. So I'll give you time to work here. So if you want to open your